Good evening and welcome to the GMAETS 41's live class. I know you've been looking ahead to this class. And of course, as always, the GMAETS 41's academic firepower always on high alert. And you know what it's going to be tonight as we look at current electricity in physics. So once again, I say to you guys, welcome to this class tonight. So as we have on the board, we are going to be dealing with current electricity. In our previous physics class, if you recall, we treated the concept of electrostatics, which extended into capacitors as well too. We were supposed to deal with current electricity, but for the sake of time, I told you that we're going to handle current electricity separately. So I hope that you are ready for our class tonight. You're writing materials with you, and you're very set to follow up with the class. So you know how it used to be, as usual. Once you connect to the class, please do well to share the link. The link of this live class, share it to your friends, those preparing for JAMB and WAEC. My dear university students, those in 100 level, if you connect to the class, share this class link right away to your departmental WhatsApp group. Encourage them to join the class. The light reflection has wiped off that interfered with our H. All right, so let's see what I will do. Physics. So the topic you're looking at is current electricity. Black GT, you're welcome to the class. James Idowu, you're welcome. Amarachi, good evening, you're welcome. Pascal Ikedi Chigemezu. I'm glad to see you guys, How are you doing? Welcome to the class. Good evening. You're welcome. Surrogate. Gosh, what is physics? Can you tell me, please? We are not here for that, young man. Then this thing is still interfering. Although it's physics, but I don't want that stuff to interfere. Let me see if I can shift my hand a bit this way, so that at least so you join, you would know that this is a subject we are treating: current electricity. So I want to tell you guys something before we move on to this class fully. Already, I have dropped the video lesson that deals with the concept of current electricity. The video lesson link, I dropped it in the GMAETS 41's WhatsApp group. Yeah, I think that is actually in our JAMB WhatsApp group, JAMB and WAEC WhatsApp group. But all the same, I've always advised you guys, make use of the GMAETS 41's playlist on this channel. There you have all these video lessons, because we are going to move right away to the questions we have under current electricity to deal with. There is no time, and I will not be copying the question on the board. Ngacha Angel, you're welcome to the class. So we're going straight on to the questions we have dropped by group 1, I guess, of the GMAETS 41's JAMB and WAEC class. And then, of course, we're going to look at the questions. Possibly, if I have some more, I will add up. So I'm trying to trace out the question from our group. I've always told you guys, you want to be part of what is happening at GMAETS 41, you want to know our class schedule, make sure you contact GMAETS 41 on this number on WhatsApp. All right, someone just contacted GMAETS 41 today, and I can tell you that the person is already in our WhatsApp group and has information about this class. There are still many others, so you too can do that. Are you following? God said, I'm trying to locate the questions that have been dropped by group 1. So let me get it out. For the sake of our friends that joined the WhatsApp group today, our new friends, I will copy that, the questions that were provided by group 1. I will copy it. I'm posting it now in our WhatsApp group. I'm reposting it. I've reposted it and I'm going to pin it for everybody to see. Okay, so that has been done. That has been done. And this gets us ready for the questions that we have for the day. As a summary, what are the things you want to give attention to when dealing with current electricity? First and foremost, the concept of Ohm's law, very important. Okay, you want to give attention to ohmic and non-ohmic conductors. You want to give attention to the graph that follows Ohm's law, where you plot voltage against maybe current. You want to give attention to the concept of resistor arrangement, when resistors are arranged in series and in parallel in a circuit. How do you get the equivalent, the effective, the combined, the total, the resultant resistance? How do you get it? You want to give attention to that, and so we might be seeing questions on them tonight. You also want to give attention to the concept of electromotive force, EMF, which is the potential difference that is set up between the terminals of a cell when that cell is not delivering current to the external circuit. Like I said, on this channel, under Physics 101/Physics 102, in our playlist, you have this video lesson covering this whole aspect. You also want to give attention to the concept of terminal potential difference, the concept of lost voltage, the relationship between EMF, current, external resistance, and internal resistance. Very important, you give attention to that. You want to give attention to galvanometer conversion, how to convert a galvanometer to an ammeter using a low resistance material called the shunt, and how to convert a galvanometer to an ammeter, to a voltmeter. Yeah, to a voltmeter. I've talked about converting galvanometer to ammeter. Use shunt there. Then how to convert a galvanometer to a voltmeter. You use a high resistance material called multiplier. The calculation is also very important. We hope we can see a question like that in our live class tonight. Then again, under current electricity, you want to give attention to the concept of the relationship between resistance and resistivity. You also want to give attention to the temperature dependence nature of resistivity. Yeah, resistivity depends on temperature. There is this equation that you are expected to know. Good enough, that equation is a bit related to that formula we saw under thermal energy when we treated the concept of linear expansivity, area expansivity, and cubic expansivity. Resistivity has one sort of relationship like that with respect to temperature. So you want to get to know this. And then, conclusively, you should know the concept of power in an electric circuit. Okay, so electrical power, very important, and then electrical energy. Very important. Once you've been able to go around this concept, you are good to go. You are good to what? To go. And of course, deal with the concept of current electricity. All right, so I hope we are together. I hope we are together. We actually look forward to network not disturbing us in this class. In our previous maths class, network messed up. All right, guys, so let us move on straight on to the questions we have. I've given a breakdown of areas you want to give attention to. So our very first question here, pay attention as I dictate it. What is the unit of electrical energy? What is the unit of electrical energy? That's question number 1. Remember, these questions are JAMB and WAEC question related. They are possible JAMB and WAEC questions as you prepare for your 2025 JAMB that is coming, just to think, in 2 weeks' time, right? After this week, the next one, I guess so. So you could see a question like that. Then those in advanced level, also 100 level, can also see a question like this in your physics. What is the unit of electrical energy? Option A, watt. Option B, volts. Option C, ampere. Option D, kilowatt hour. Kilowatt hour. And the question is, what is the unit of electrical energy? The correct answer is option D. Option D. That's the correct answer. Kilowatt hour as presented here. It's actually joule per second. But that joule per second can be converted to that watt hour concept. The reason is, like I said anyway, the correct option to question number 1 is that kilowatt hour. That's the correct option. Kilowatt hour. Although this is not basically the SI unit. It is not basically the SI unit, because the SI unit shouldn't have kilo in it. All right. But all the same, just watt hour. And let me show you why. If you are talking about electrical energy, power first, power P is equal to the rate at which energy is being expended. So if you're talking about electrical power, is equal to electrical energy divided by time. Now, if you cross multiply, you are going to find out that electrical energy is equal to power times time. And I want to ask ourselves, what is the unit of power? The unit of electrical power, unit of electrical power of P is joule per second. This joule per second, which is obtained from here, unit of energy, joule over second, per second. Altogether, this thing is the same as watt. Joule per second is also known as what? Watt. So if that is the case, it implies that the unit of energy, unit of electrical energy E, will now be the unit of power times the unit of time. And the unit of power, like I said here, is joule per second. Then times this. I can work it out. If I don't want to use joule per second, I can use watt. Because joule per second is watt. Then remember that the power is multiplied by time. So it's going to be watt times the unit of time, which is second. But an examiner can decide to give it to you in minutes, in hour, like you saw in this question. There should not be any kilo if it was SI unit. In SI unit, it is either joule, the unit of energy, will simply be joule, or watt second. Watt second. Still the same as that. But the examiner decides to give us the metric prefix unit, and that is still cool. This is going to be watts for power, then times the unit of time. A unit of time, in this case given, is, permit me to use second here. I'm going to use second. Then that watt second in other metric prefix units, in other units. Other units can be given as this whole thing you are seeing is joule, or joule. This whole thing you are seeing, watt second, is joule. Then in other unit, like I said, other units, this can be written as kilowatt hour. Kilowatt hour. All right, kilowatts hour. Where I think we use kWh for it, in case you see something like that. Anyway, I think I've made the analysis, as you can see on the board. Okay, generally the unit of energy is joule. Joule. But the examiner has decided not to give you joule there. The examiner gave you watt, which is unit of power, gave you volt, which is the unit of potential difference of voltage, gave you ampere, which is the unit of current, and then gave you kilowatt hour. Kilowatt. Kilowatt. If you don't like, you can remove this hyphen. It doesn't matter. You can remove this hyphen and then put the hyphen here. Kilowatt. Because the kilo goes with the watt. All right. And that, of course, is the correct answer. The analysis has been done, like I said. Let's move on, please. Question number 2. What is the term for the flow of electric charge? What is the term used for the flow of electric charge? Option A, voltage. Option B, current. Option C, resistance. And option D, power. Question number 2. The correct option, what is the term for the flow of electric charge? Whenever electric charge flows, we refer to that term as current. That is what we call electric current. And that is option B. That is option B. Okay, electric current. Electric current is simply the flow of charge per unit time. And remember that I, electric current I. Electric current I is equal to charge divided by T. So the flow of charge, the rate of flow of charge, the amount of charge that flows per unit time, that gives you current. And of course, that answers this particular question. I've added further information for you to know the formula of electric current with respect to the fact that electric current is the term you use, is the definition of the flow of charge per unit time. This takes us to question number 3. Now, these are simple concepts to just, anyway, the topic is simple. Question number 3, we have this. Which type of circuit has only one path for current to flow, for electric current to flow? Which type of circuit has only one path for electric current to flow? Option A, series circuit. Option B, parallel circuit. Option C, closed circuit. Option D, open circuit. The correct answer here is option A, series circuit. Question number 3. Option A. That's the correct answer. Series circuit. You know, a series circuit allows current to flow in one direction. Which type of circuit has only one path for electric current to flow? Series circuit, in the case where maybe if it is resistor, you have something like this. I think last class I drew something of this kind, so I don't really have any need redrawing it. But this is series R1, R2, R3 in that order. It can be any other electrical material. If current enters I, the current is flowing along one path, straight on like this. For parallel, current will divide. I said it in our last physics class. Are you following, right? And I think under capacitor, I showed you series and parallel circuits. So that is it. Series circuit allows current to flow in one direction. Parallel circuit divides current. An open circuit is one in which current does not flow. A closed circuit is a circuit that is complete, in which current is allowed to flow. But the type of circuit that tells us the dimension of current flow, that is, in how many directions can current flow, that type of circuit is either parallel circuit or series circuit. Series circuit allows current to flow in one direction, while parallel allows current to flow in more than one direction. Should I just leave this diagram anyway? We move on to question number 4. Question 4. And the question reads, which device is used to measure electrical current? Which device is used to measure electrical current? So question number 4, options. Option A, ammeter. Option B, voltmeter. Option C, ohmmeter. Option D, multimeter. The correct answer is ammeter. Ammeter is the device used to measure electrical current. Electric current. So the correct option, like I said, is option A. That's the correct option, ammeter. Ammeter is used to measure electric current. This takes us to question number 5. Question number 5. Question number 5, the question reads, I hope you guys are following what we are doing here, right? Good. John Huth. Right? Your answer is correct here. Ammeter is used to measure current. You know, in the thumbnail of this particular live class, you saw 2 instruments. You know, in the thumbnail, one is an ammeter, the other is voltmeter. Voltmeter is a device used to measure potential difference or simply voltage. Is that okay? So you want to take note of that. Okay, so we're moving on to question number what? Question 6. And it reads, is it question 6 or question 5 rather? Electrical resistivity of a given metallic wire depends on electrical resistivity of a given metallic wire depends upon, I read the question again. Electrical resistivity of a given metallic wire depends upon A, its length, B, its thickness, C, its shape, D, nature of the material. And the correct answer here is the length. Electrical resistivity depends on the length. It does not depend on the nature of the material. It doesn't depend on the shape, the configuration. As a matter of fact, when you are deriving, okay, if you are deriving the resistivity formula, I have a special video lesson that deals with the derivation of resistivity. We assume that the material is isotropic. What do we mean by being isotropic? It means that the material's dimension is the same and the properties of that material is the same in all directions. So it means that the shape, the nature of the material does not affect the derivation of resistivity. That is an assumption we make. Like I said, I have a video lesson in that on this channel. Always make use of our playlist and you will love what you are learning. So the correct answer is length. And without wasting much time talking about this, I'm going to show you the correct option, like I said, is A. Option A. Its length. Resistivity depends on what? Length. And how can you actually verify, or what can easily guide you if you're an examiner to know that resistivity depends on length? This formula should always be in your mind, right? It should be at the back of your mind. Resistivity is equal to resistance times area divided by length. This symbol is resistivity. This guy is what? Resistivity. Resistivity. So you notice that resistivity depends on length. L here is length. All right. Then A here is area. So resistivity of a material depends on area. It also depends on length. But I want you to take note of how length affects resistivity. This is an inverse relationship. It means the longer a wire, the lower its resistivity. And the shorter a wire, the higher its what? Resistivity. The knowledge of variation in mathematics, inverse variation, explains this relationship. Anyway, I have answered this, that resistivity depends on the length of the wire. But You want to take note that resistivity also depends on the resistance of the material. It also depends on the area of the material. This equation is very important. This is the equation you use to study factors that affect resistivity of a material. Resistance is one, in which resistivity is directly proportional to resistance. Then area is another one, in which resistivity is directly proportional to area. And finally, length is another one, in which resistivity is inversely proportional to length. All right, guys, we've taken some good questions where, no calculation. It's just certain things you should know, right? Non-calculation aspect of this. There are still other non-calculation part of current electricity, but at least the ones provided by the GMAETS 41's group 1. But as we move on, I see other questions that maybe are non-calculation. It's possible. All right, it is what? Possible. But at least the first 5 questions here, they are non-calculations. Let's see what we've got in our question number 6. Question 6. I hope you are following up with the class. King Newell. All right, thank you for indicating that you are following up. We are moving on. We've got like 20 questions supplied by group 1 of the GMAETS 41's JAMB and WAEC student. Like I said to our dear advanced level students, those in 100 level, even in 200 level, if you're dealing with any course that is related to electricity, this concept is something you should, in fact, as a matter of fact, you must know. Do you understand that? So this is not just all about WAEC and JAMB. I always say this in my classes. So you want to be aware of that. Okay, now let us move on to question number 6. Right, question number 6. I will read the question, but although there is something in that question that seemed to make the question somehow incomplete, but let me dictate it and then let me see if I can use my experience to adjust what the question should be like. Follow along question 6. A current of 1 ampere is drawn by a filament of an electric bulb. I'll take that again. A current of 1 ampere is drawn by a filament of an electric bulb. Number of electrons passing through a cross-section of filament. Number of electrons passing through a cross-section of filament in 168 would be roughly, that is the question. I read it again so you understand what I mean by this. A current of 1 ampere is drawn by a filament of an electric bulb. Number of electrons passing through a cross-section of filament in 168 would be roughly. This is why, dear friends, as a science student, you don't joke with units. You don't joke with it. As a matter of fact, if you're sitting for a theoretical exam, for example, and something, a number is supposed to bear a unit, a number represents a quantity, and you don't indicate the unit, the examiner has the right to fail you. Because you're not quoting the unit of that guy if that quantity is not dimensionless. Because dimensionless quantities do not have units. For example, strain under elasticity, it doesn't have unit. We know that one is dimensionless quantity. But in the case where that thing is not a dimensionless quantity, it's supposed to have a unit, you don't indicate it, you are causing a whole lot of trouble to the reader. Like in this question, I don't know what that 168 represents. Listen to the options provided. Option A, 1020. Option B, 1016. Option C, 1018. Option D, 1023. Number of electrons passing through a cross-section of filament in 168 would be roughly. So I don't even know what to do here, to be honest. I feel that 168 should be talking about maybe time. where you talk about the current that is drawn from that filament, right, in 100 and maybe 68 seconds. Or could it be that that thing is 16 seconds? But if I assume it to be 16 seconds, how about thinking it to be in the unit of minutes? Okay? How about thinking it to be in the unit of minute? But I know very well what this question likely could be. It could be something like trying to adjust something. Are you following, right? It could be something that, okay, the current was given to you to be 1 ampere from the question here. All right. And then I am assuming that 168 is time. But if I assume it to be 168 seconds, I might get into trouble. Why? What we are asked to find here is the number of electrons passing through a cross section of filament in 168 blah blah blah. I don't know what the unit is. Let me assume, okay, electrons is charge. Electrons is charge. So let me assume that we don't know charge Q. That will imply, remember, that Q is equal to IT. So if I assume this, it will now mean that the number of electrons flowing will now be current times time. If you multiply this current 1 ampere by 168 seconds, you cannot get any of the values as provided in the option. You really cannot. So there is an issue here for me. I don't know. I really, not something like this. Now, if I assume that, okay, let this thing be, let it be, okay, let's say 16 minutes, for example, 168 minutes. 168 minutes, that is instead of second, you use minutes so that you can convert that 168 seconds to minutes. If that is the case, if I assume that thing to be 168 minutes, multiplied by 30, is it by 30 or by 60? Because to convert from minutes to second, you multiply by 60. How fast can you multiply this? Use the 6 to multiply these guys. 6 times this will give you 48, right? 8 carry 4. 6 times this is 36, plus the 4 will give you 40. Right, 0, carry 4 again. 6 times this, it's going to be 6. Plus the 4 you carried is going to be 10. Then you attack 0 here. That should be there about 10,080. 10,080.